All righty, there you guys are. Okay, welcome to our first day of MAC1140 pre-calculus. My name is John Filesticker, or Professor Filesticker. You can call me JP or Professor John, whatever you're comfy with. Today being day one, we're going to do the normal day one stuff. I'm going to walk you through the syllabus, talk a little bit about how the class is going to run, introduce you to the way you're going to take notes, all of that stuff. But then we are going to get started on some mathematics. You do actually have a homework set that is already up, and you want to begin on that immediately. So let's get to it. Let me show you what this class is going to be like, what you're expected to do, and all that good stuff. Just a quick warning before we get into it. I do record all of these lectures. You saw the recording notice. So if your camera's on, you will be recorded. I do post the recordings to YouTube after the fact. So just be mindful of what's going on around you. But it is lovely to see your faces. It's nice to get to know you guys a little bit. So I do appreciate those of you who are very comfortable, whatever, turning on the camera. That's very nice. All right. So I suppose the first thing to do is to show you this. This is the document camera, which I'll be using to deliver the notes. Think of this as the blackboard. Everything that I put on the doc cam should go into your notes, today included. I know it's day one, but you definitely want to take notes. Every day will begin like this. This is MAC1140. The section number is 009. That's something you'll want to remember. Of course, it is pre-calc. And today's date is August 24th, 2021. Today, we're going to do the normal day one stuff, which includes things like going over the syllabus. I'll show you the Canvas course and WebAssign a little bit. And we're going to talk about class policies. After that, we are going to do some mathematics. We're going to begin chapter 1, which is going to go very fast. It's all just some preliminary stuff. Things that I would like to pretend everybody remembers from high school or college algebra, but I know better. So we're going to do a little bit of that. We're going to do it very quickly. That's it. That's the roadmap for today. So I think the best thing to do is just go through here in order. We're going to begin with the day one stuff. Let me start by showing you the Canvas course. That'll get us to the syllabus. Then we'll go to WebAssign and talk about the rest of it. Let's see, I do see some things in the chat. You guys having a hard time hearing me? Is that still the case? A little bit. Let me see if I can play with the microphone settings. I'm going to disable and re-enable the microphone. Give me just 10 seconds here. All right. Tell me better or worse. Now. Nothing now. Okay, how about this? All right, good. I think this is the highest quality of the 3 microphones hooked up to this computer. So I'm going to stick to this one. If you do have trouble hearing anything, just let me know. I'll speak up a little bit or I can follow up. Very good. All right. So, yep, we're doing this stuff today. All of this stuff. We're going to start here. Let's do these things. Obviously, you all made it here, which means you figured out how to get to Canvas, or at the very least, you were able to receive the Canvas announcements. When you come into Canvas, if you haven't done it yet, if you're just using your phone or something, follow to our class here, and you should see this stuff. My name, John Filesticker. You can pronounce the last name if you want, Filesticker, or you can just call me John or Professor John or JP or whatever you're comfy with. I don't give a shit. Class meetings, obviously you figured that out. Tuesday, Thursday, 12:30 to 1:45, and the announcements will always contain the Zoom links, separate announcement for each day. Office hours right now are set to Monday, Wednesday, and Friday from 1 to 2 p.m. I am thinking about adding another office hour, so if this does not work for you, you can never come to this. Send me an email or Canvas message letting me know, and that will help me pick where to add more office hours. If you do want to come to this office hour on a Monday, Wednesday, or Friday between 1 and 2 p.m., just click this and it will launch a Zoom meeting. I do use waiting rooms for the office hours because sometimes people like to discuss things in private, like grades, family issues, whatever, all that stuff. So if you wait in the waiting room for a minute, you don't get any messages or anything from me, just send me a little DM in Zoom saying, hey, I've been waiting for a second. Can you bring me in? And I'll get back to you right away. All right, today I'm going to ask you to actually do a few things. The first thing I'm going to ask you to do is get out your phone, open your calendar app, and put this in it right now. Your final exam is December 7th from 1 to 3 p.m. Put that shit in there now with like a notification the day before, a notification an hour before, whatever it's going to take to make sure that you are definitely there, because Santa Fe's final exam schedules are very rigid. It's hard to move things around. If you miss the final, that is bad news bears. Alrighty. The next thing I want to show you is how to get to the tutoring. So if you haven't used Santa Fe's tutoring in the past, right now we're doing both in-person tutoring and online tutoring. Follow the link in Canvas there, the one that's on that home page. Scroll down to Math and Statistics, and you'll see the, the hours here. If you want to come to campus, go to the library and get direct tutoring at the Learning Commons from a human being standing next to you. You can do that any of these days and times, and the tutors there are pretty solid. If you want to get tutoring online, the hours are slightly more extended. They go a little bit later on the weekdays, and you can do that during these days and times. If you want to do online tutoring, if you actually want to get hooked up with a tutor online, click this link up here, the Learning Commons Canvas page. That will take you to a separate page within Canvas. You do need to be signed into Canvas for this. Then click here for Math, Sciences, and Business Tutoring. And then you would click this Zoom link right here, and that'll plop you into a meeting where they'll ask you, hey, what do you want help with? And then you tell them, hey, I'm in pre-calculus, I want help with this, and they'll match you up with a tutor who can help you out. Alrighty, so the Learning Commons really is a great thing. We've been pouring tons of money and time into it over the last few years, and it has come a long way. If you went to the Learning Commons a year or two ago and had a mediocre experience, give it another shot. Give it another shot. I'll also say this, if you have a great experience with a tutor, let me know. I really want to know that. If you have a bad experience with a tutor, I really want to know that. Please let me know. Write down their name, reach out to me, and we will take care of that shit, because I don't want anybody having negative experiences that go unfixed, unreported. So let me know if something goes well, that tutor deserves a pat on the back, a raise, whatever. Let me know if it doesn't go well, if that tutor needs a little bit of correction. That's all good information for me to have. So that's how you get to the tutoring, right? Follow this link and then just kind of follow your notes. Go to Math and Science Tutoring, click the link to go to the Learning Commons Canvas page, and then go to Math Tutoring. Other places for you to get help in this class, you'll see in the announcements, there's a link to a Discord chat server. I have that up here. This is all of my pre-calculus classes for this semester are in one chat server. So it's not just the folks who are in your class, it's anybody who's taking MAC1140 with me this term. And I'm also inviting a few people from the math team. Santa Fe has a competitive math team. I'm bringing some of them in to help answer questions. And some students from my differential equations class over the summer may pop in or out to help there as well. You can share whatever you want here. You can post memes, you can complain about my handwriting, you can complain about the tests, you can ask homework questions. You can ask questions about due dates, whatever you want. Anything you want to talk about, I invite you to talk about in here. I'll be moderating it very, very loosely, just coming in to answer questions once or twice a day. All right, going to go back to the home on our Canvas page, and we are going to open up the syllabus. So the next thing I'm going to ask you to do is I'll click this link right here and save a copy of the syllabus somewhere on your computer. So you click that link, it'll give you some options. Don't open with either of these things, save the thing. If you don't have one already, I strongly recommend you create a folder somewhere, probably on your desktop for classes, and then create a subfolder for this class. And you see I already have a copy of your syllabus saved there, but I'll just save over it. All right, that sort of organization is a really good thing. You want that. Then we can open this up. Oh, I forgot it defaults to that. It's so annoying. All right, here is your syllabus. So we're going to talk through this together. I know this is nobody's favorite part of anything. I'll try to do it quickly. This is me. I'm an assistant professor here at Santa Fe. I finished grad school at UF back in 2016, studying number theory, analytic number theory, partition combinatorics. I've been doing math for a long time. I've been teaching math for a long time. I've taught, obviously, here at Santa Fe. I taught at UF for a few years. I taught at UCF for a few years before that. So if you have questions about, universities in the state, their math programs, anything like that, I can probably help you out a little bit, transfer questions, stuff like that. My physical office is A031D. That's downstairs on the north side of building A, although I'm not there very much. I have an infant son, so I'm still teaching remotely to try and keep him safe from COVID. But if you need to drop something off physically for me, you're trying to get an actual piece of paper or something to me, you can take it there and our secretary will make sure it gets to me. This phone number rings in my office, and during daytime hours, I do have it set up to forward to my cell phone, so you can get a hold of me through that. But because it's forwarding from a landline, I don't have caller ID and I don't have voicemail. So if you call from this, I won't be able to see caller ID and I won't be able to check voicemail. So I definitely recommend, if you're trying to get a hold of me, email is the best way, or even better is a Canvas message. Since you're currently enrolled in the class with me, sending me a Canvas message automatically puts in the subject line what class you're in, what section you're in, and your name. That's beautiful. That's exactly what I want. If you do choose to email me directly, you can click this link. It's a mail to link. I just ask that in the subject of that email, include MAC1140.009. And then also, please, if you're sending me a direct email, do so from your Santa Fe email address. I'm not supposed to reply to Gmail or other addresses. Class meetings again, Tuesday, Thursday, 12:30 to 1:45, office hours 1 to 2 p.m. or by appointment. Again, if you can't make one of these, but you want to talk, send me a Canvas message and we'll arrange a separate one. If you can't make any of these, definitely send me a Canvas message. That will help me choose where to add more of them. And then finally, if you want to meet in person rather than on Zoom for an office hour, I'm happy to do that. You can go up to campus and we can reserve a classroom to meet, work some problems, do whatever sort of office hour thing you want to do. I will ask that you wear a mask for that because, again, infant son, trying to be careful. The final exam is Tuesday, December 7th from 1 to 3 p.m. And that is something that you need to put in your phone's calendar if you have not already done so. In order to get into this class, you need to have passed college algebra with a C or better or earned the equivalent score on the placement exam. The textbook we're going to use is Stewart's Pre-Calculus. It's in the 7th edition now, although you do not need to buy a physical copy of the text. If you want one, here's the ISBN. You can search that on Abe Books or Amazon, wherever you like to buy books. One thing, really the only thing that you are required to buy for this class is a WebAssign access code. So you can get these using financial aid at the bookstore. You can order them directly through Cengage online. You can buy them secondhand on Amazon or Abe or other book resellers. Usually you can get them quite cheaply there, but you want to make sure that you're not getting scammed. If you intend to use your financial aid, I do believe if you're going to charge it to financial aid, you have to go through the bookstore. The access code is like your proof of purchase. It's how you tell the people at WebAssign, yeah, I paid for this shit. The thing you need to tell them what class you're in, to tell them you're in my pre-calculus class, is the class key. So when you go to register for this class in WebAssign, and I'll show you what that looks like in just a second, you'll enter this class key. Then it'll probably ask you for some information, and at some point it's going to ask you for your access code. If you've already got your access code in hand, then go ahead and put that in. If you don't have your access code in hand, scroll down, look around on that page. There will be a little link that says register using temporary access or register using trial access. Click that. That way you can get in and get started right away. You need to do that. I need everybody registered for WebAssign today because you already have homework in there. You do not want to fall behind on the homework in this class. So again, even if you don't have your access code yet, you can register for the course in WebAssign. Just use this class key. That's how you tell WebAssign which class you're in. And then sometime within the next 2 weeks, you need to get your hands on an actual access code and put it in. Otherwise, they will kick you out of WebAssign. You do not need a calculator for this course, but I know a lot of people just feel more comfortable having one. The calculator that you're allowed to use for this class is the TI-32XS. This is the only calculator you're allowed to use on tests. So if that's you, if you just feel comfier with a calculator in hand, I get it. A lot of folks are like that. That's fine. Grab yourself a TI-32XS. They're about $10 at Walmart. If you find it cheaper somewhere else, let me know. But that is the cheapest I've seen them so far. Specifically, graphing calculators or calculators that can do symbolic stuff like the TI Inspire are very much not allowed. One of the big goals in this class is getting you to graph functions well by hand. And obviously, if you're leaning on a graphing calculator or Desmos on your phone or something like that, then you're not learning that shit. So please, I encourage you to practice the homework problems the way you would do the test problems, using at most this thing. Other things you're going to physically need for the class: a computer with an up-to-date web browser. If your browser tries to update, please let it update. Don't push those updates back and back and back and back and back. That can cause problems with some of the software that we're going to use. You also need consistent internet access. And I know this is a sticky one because, for example, where I live right now, I don't have very consistent internet access. Cox Cable, they are just the worst on the planet. I've filed FCC complaints with them. They're a forever pain in my ass, but that's why I have a backup, right? The hotspot on my phone I know is fast enough and has sufficient bandwidth that I can run these classes using that hotspot if I have to. If you are like me and your internet access at home is not super duper 100% reliable, then you need a backup too. Because if your internet goes out during a test, or if your internet goes out during any sort of proctored event, that clock is going to keep ticking and you don't want to lose that time. So make sure you have either rock solid internet access or a backup. The backup can be the Wi-Fi hotspot on your phone. It can be the coffee shop up the street. It can be just going to campus, right? If there's a test day and you know your internet is spotty, maybe go to one of those places first or have a good backup in mind that you know is reliable. Other things you're going to need, got to have a working webcam. Obviously, it's not necessary that you have your camera on today, but for the exams, you will need to have your working webcam. That's for honor lock. The other thing you're going to need that's not listed here is a smartphone, and I know you all have one. But if you don't have a smartphone, I can help you get a hold of one for the days when we will need it. The reason you're going to need a smartphone is because the way the exams are going to be proctored for this course, we will use honor lock. Honor lock will record your face with the webcam. It will record your screen and your web traffic. But before you even start the honor lock process on those exam days, you're going to sign into a Zoom meeting on your phone. You're going to set your phone up somewhere over here where I can see your desk, your lap, your hands, your paper, all that shit. And you will not be allowed to begin the test until getting the okay from me on your Zoom smartphone setup. So I know everybody has a smartphone or an iPad or something like that that can install Zoom on, but if for whatever reason you don't, just let me know and I'll get you one you can use for those things. All right, that's the stuff you need. Course description. This class, together with MAC1140, which is trigonometry, is going to get you ready to take the calc sequence, calc 1, 2, and 3. We are going to study polynomial functions, rational functions, algebraic, logarithmic, and exponential functions, and piecewise combinations of those. So we're going to study a bunch of different families of functions in detail. We're going to actually begin by talking about functions in general and studying, kind of what functions are and basic properties and notation associated with functions. Then we'll go into the detailed study of each of those families. Throughout the whole thing, the emphasis is going to be on graphing. Like I said a minute ago, graphing is the key here. After we get through that kind of detailed study of functions, we will talk about conic sections. We will talk about some interesting inequalities. Turns out solving inequalities, solving equations, very different. You need different skills to solve inequalities, and calculus is all about inequalities. So that's a big chunk of the class. And then the end of the class, we are going to talk about systems of linear equations, matrices, which are these beautiful tools for abstracting from a system of equations to a whole different algebraic object. We'll study the algebra of matrices, these things called determinants, which are really neat connected to matrices. And then we're going to finish up the class by talking about sequences and series. If you want to read the full official course description, course objectives, you can follow that link. It's all right here. I'm not going to do that today. Cell phone policy, not super relevant because we're obviously in a Zoom class, but the general ethos is the same. Don't use technology in a way that distracts other people during class. So there is the Discord for this class. I would ask that you not blow up the Discord during the class meeting because that's distracting. There is a chat feature built into Zoom, obviously, and I would ask that you keep the chat focused, right? So ask questions that are relevant to the class, things like that. But no memes in chat, no like random shit in chat during class, please. Just be polite, don't distract other people. Speaking of the chat, I see Cengage keeps giving me errors left and right. I've been trying to log in since yesterday. Gavin, if you want to reach out to me, they're actually doing some Zoom office hours to help people register. I think probably they're doing those Zoom office hours to help people register because they're making changes to their API and having some troubles. So I will, I see there's somebody else having the same problem. Let me just go ahead and paste that info here. All right, this is Marlena. She is our Cengage rep. And then I'll paste the link. Alrighty, so if you look in the chat there, if you're having trouble registering for the class in WebAssign, they are doing some registration help office hour thingies every Monday through Friday, starting August 9th, going through September 2nd from 10 a.m. to 12 p.m. and 2 p.m. to 4 p.m. The meeting ID is there. You can use that to join, or you can click this link. Don't do it right now, please. Obviously, it would take you out of the Zoom meeting, but you can copy paste this into a notepad document and save it there. All right, that works. Okay. So yeah, I do apologize. Cengage, not the best company in the world, but they're working on it. And if you have any trouble there, if they're unable to help you during those meetings, let me know, and I'll make sure that we get it all sorted out. Moving on with the syllabus attendance policy, I am taking roll every day using Zoom log. Zoom automatically tells me who's here, who's not. It's very important, therefore, that you use your actual name in Zoom. So when you sign into Zoom, make sure that your name here is the same as it is on your Santa Fe ID. That's how I'm going to record and report attendance. This is important for a few reasons. First, I want to know who's coming to class and who's not coming to class. That tells me, who cares. Also, your financial aid will not disperse until I mark you as having attended the class. So for several very important reasons, please use your name in Zoom as it is on your Santa Fe ID. There is not an attendance component to the grade. You're not going to lose points for not showing up to a class. But it does kind of tell me who's paying attention, who's giving a shit. And if you find yourself asking for lots and lots of favors at the end of the semester, I may look back at my attendance records and be like, well, you never showed up. So no, that's very rare. But again, it's come to class. Please come to class. This is college. You paid for this. This matters. This isn't bullshit. Come to class. Makeups. When it comes to the homework, I'm really relaxed about this. If a homework goes by and you're not happy with how much of it you got done, just submit an extension request in WebAssign, and I'll grant it. 99.9% of the time, I'll grant it. No questions asked. You get 3 more days or a week or something like that, depending on what's going on in class. Exams are a little bit more complicated. If you miss an exam, you gotta let me know what's going on. If you know you're going to miss an exam ahead of time, reach out ahead of time and we'll make some arrangements. If you miss an exam because of some unforeseen thing that happens on the day of the test, you wake up sick or whatever, reach out to me. Even if you're sick, just send me the email Canvas message saying, hey, I'm sick, I can't take the test today, and I'll schedule you for a makeup. You don't need to give me a doctor's note. In certain circumstances, like if you missed the final or we had very little communication, then I might request some documentation. That's why that's in there. But most of the time, I'm not going to give you a hard time about it. Just let me know what's going on. I pretty much always have to do 1 makeup session per test because shit happens. So if you miss the test, just let me know. I'll put you into the makeup session. Then lastly, no graded materials after the day of the final, right? This is the last day you can turn in homework, quizzes, any of that stuff. Speaking of homework, we have homework and quizzes. So every week there's going to be 2 homework sets. Oh, and I forgot, you guys are a Tuesday, Thursday class. I need to change this. So they're going to be due on Tuesdays and Thursdays. So like you have a homework set open now. Normally that would be due on Thursday at the start of class. Because it's the first week, I'm letting you have until next Tuesday, but generally that's the way it's going to work. You'll have a homework set due at the start of class every day we meet. And that homework is going to be exactly the stuff that I need you to have practiced in order to understand that next lecture. So you have homework due every day we meet for class, and that means 2 homework sets per week, right? 1 due on Tuesday, 1 due on Thursday. The homework set that's due on Thursday is generally going to be shorter than the one that's due on Tuesday because obviously you have less time. I'm aware of that, but you need to stay on top of the homework. The whole point of having that system is so I can guarantee that you've at least tried those problems before we move on to the next thing, which is so important because, as you know, math just builds and builds and builds. There's also going to be quizzes. The quizzes will be in WebAssign. There's going to be about 1 quiz per week. I don't have a quiz set up for you for this first week because people are still adding and dropping the course. But starting next week, we'll have about 1 quiz per week. The homework problems, you have basically unlimited attempts. I don't have it lock you out of the problem after 3 attempts or anything like that. WebAssign doesn't actually have an unlimited option, so I set it to the max, which is 55. If you happen to use all 55 of those attempts, let me know. We'll figure something out. But you've got 55 shots at each homework problem, 3 shots at each quiz problem. Exams. We got 4 midterm exams. And 1 final exam. The midterms are not cumulative. They just focus on the material between the last exam and this exam. The final is cumulative, meaning it covers everything. Again, because the nature of math, it builds and builds and builds and builds. Exam 2 is going to be hard if you don't know the material from exam 1, but I'm not trying to catch you out or trick you on any of the older stuff on any of the later exams. I already mentioned the proctoring system we're going to use. We're going to use HonorLock. The exams are in Canvas. They're structured as Canvas quizzes, and we're going to use HonorLock. But before you're even able to begin the HonorLock process, you'll have to join a Zoom meeting from your phone. Set up the phone so I can see your desk, your hands, your lap, your work surface, the paper where you're writing, all that stuff. Once you get the okay from me with the Zoom setup, then you can go into Canvas and launch the HonorLock process. Those tests are all going to take place during normal class hours, during class time, like a regular in-person class would. And then the final is, again, 12/7 at 1 p.m. Same proctoring system for the final as we use for the midterms. Recording notice, we also already kind of touched on this already. Be aware if you have your camera on that I record the lectures and then I post them to YouTube. So you will appear in this little thumbnail on the far right if you have your cam on. Don't be like a student from my DiffEQ class over the summer, had a 4-foot tall dab rig right behind him the whole damn time and didn't realize it until his parents yelled at him. Be smart about it, right? Just let your roommates know what's going on, that sort of stuff. Important dates. Obviously, classes started on the 23rd. Today is our first day because it's a Tuesday, Thursday. The last day to add a class is tomorrow, the 25th. The last day to drop a class, get your money back and nothing on your transcript is the 27th. So by this day, you want to decide if you're going to stick with the class or not, right? If you just hate the format or like pre-calc is not the thing for you right now, or you hate my handwriting or whatever, the last day to get out of here, get your money back and have no consequences is the 27th. There are a handful of holidays. I don't know why. We're closed for UF Homecoming. We're also closed for Labor Day on the 6th. The last day to bail on this class and get a W, you no longer get your money back if you stay past the 27th, but if you withdraw from the class before the 2nd of November, you won't receive a letter grade. You just get a W on your transcript and move on with your life. Withdrawing beyond this date requires the petitions process. You have to fill out like a paper and get a letter and some support and other stuff and send it to the petitions people. It takes a while. So I strongly urge everybody when this date rolls around, the 2nd of November, take a look at your test grades, take a look at your homework and quiz grades so far, try to kind of estimate where you are and if you're going to be able to get what you need out of the class. And if the answer to that question is no, it may be wise to go ahead and withdraw on that date, because if you stay beyond that date, you will get an A through F letter grade. I also encourage you to talk to me around this time, especially if you're having a hard time deciding, you're not sure whether you should stay in the class or not. Talk to me, talk to people in advising, and see kind of what your options are and where things might go. So don't let this date go by without any thought. This is another one I would put in your calendar. November 11th, we're closed for Veterans Day. The 25th and 26th, we're closed for Thanksgiving. The last day of class is December 2nd. That will be our last actual meeting. Your final is again on the 7th at 1, and then the grades will be posted to eSanta Fe no later than December 14th. Speaking of the grades, here is the breakdown. The homework is about 7% of the grade, that's 45 points. The quizzes are 75 points. We're not really doing labs right now because of the online thing, but the quizzes are 75 points, and that's about 11% of the grade. The midterms are 100 points each, and there's 4 of them. That's 400 points, makes 60% of the grade. And the final exam is 150 points, which is 22% of the grade, right? So you see that the vast majority of the grade comes from proctored tests. So you really need to prepare for these. It's not something to take lightly. The tests are almost everything. The grading scale we use is the standard one. 90 to 100 is an A, 80 to 90 is a B, and so on. The top 3% in each one of those categories gets the plus designation. So like an 88 is a B plus, a 77.5 is a B plus. One of the things people always ask me is, do you round up? Like if I have a 79.5, can I get a B? Yes, I do. The rule for that is if you're within 1.5% of the next grade. So like a 78.6, that's a B. 78.4, that's a C plus. I see a question in there from Sarai. October 1st is a Friday. Is the college closed for the whole week? No, I think just the day. Yeah, 10/1. Yeah, just the Friday. Definitely not closed for the whole week. All right, moving on, the next page in the syllabus, this is all kind of boilerplate syllabus stuff. It's stuff I have to have in there. GELOs, General Education Learning Outcomes. These are some particular questions on the tests where I track statistics, not for you individually, but for the class as a whole. These are things that the state likes to monitor to see how well I'm doing my job. They have no bearing on your grade. They don't show up on your transcript, nothing like that. It's just something that helps the state decide whether I'm doing a good job or not. Academic integrity, I'm going to talk a little bit more about this in a minute, but I strongly recommend that you at least skim the content of this link. It's got a lot of very technical, kind of legal sounding definitions. All of those are words that you know anyway, and they mean what you think they mean. But it's a good idea to know the rules that you're going to be judged by. And especially right now with everything online, there's a lot of academic integrity shit going on. I'll go into that more in a second. The Americans with Disabilities Act, the ADA, it's a wonderful law that says, regardless of your disability status, you are entitled to good treatment. If you are registered with the DRC or think you may qualify to be registered with the DRC for exam accommodations, note-taking, anything like that, please let me know. Even if you haven't registered with the DRC, you're waiting to hear back with them, they can move a little bit slow with the paperwork sometimes. I want to make sure you have the accommodations you need. So if anything like this comes to mind for you, please reach out to me. I'll be happy to help. Similarly, accessibility, all the materials for this class are coded in the LaTeX markup language published as PDFs, including the stuff that's on Canvas and the tests. So all of that should work well with screen readers. You shouldn't have any problems if you're using any sort of accessibility hardware software. But if you do have any problems with that sort of stuff, just let me know. The DRC people are really good at helping out with that, and I can also help as much as I can. Discrimination, harassment, this should go without saying, just don't be an asshole. Be nice. Be nice to each other, be nice to me, be nice to other people at the college. That's all. Just be nice. Don't stalk anyone or hurt anyone or anything like that, please. Your rights and responsibilities as students, same sort of thing as the academic integrity stuff up there. I strongly suggest you read this and get some idea of what it says, because those are the rules that you'll be judged by if something does go wrong. Okay. That gets us to this section. So I'm just going to read it first and then we'll talk a little bit about it. I know that right now the temptation to be dishonest in the exam setting is great. I know that not all the instructors have been as careful in enforcing the rules as they ought to be, but I take this shit real seriously. I do watch your honor lock videos while I grade. I play them at double speed. I watch every single one of them. I will not hesitate to start a conduct trial in any case where I think there's even a chance that someone has been dishonest, cheated at all. Just to be clear, using apps like Photomath, Wolfram Alpha, Bartleby, Googling questions, Mathway, fucking Symbolab, anything, communicating with somebody else on any platform, seeking help from any outside source or anything at all like that is fucking not allowed. And I will come after you hard for it, I promise. Story time. Over the summer beat, I taught a MAC1140 class, and the greatest number of people I caught cheating at one time was 6. One test, 6 people. They were in groups of 4 and 2. 2 people copied answers from each other, and then 4 people used Mathway. I run all my own shit through Photomath, Symbolab, Mathway, Wolfram, Bartleby, everything. I know what the output from those bits of software look like. I know what good, honest work looks like. And if I see something, I'm gonna go after it, right? If I see something that looks a little bit suspicious, even if it doesn't match the output from any of the cheating software I know, I'm gonna send it to my colleagues and ask them, hey, do you know anything that would output this? Does this look weird to you? If you cheat like that, I will catch you. I know not every other professor is great at catching this sort of stuff. I know a lot of people have used that sort of stuff over the last year and a half to get through classes. I'm sympathetic with that. I get it. It's tempting. And it, in some settings, is easy, right? I've seen it. It's not easy in my class. It's really not. This is not something I like doing. I want to be clear about that too. I hate doing this stuff. I don't take it, I'm not like personally offended by it, but the reason I'm like this is to keep the value of your degree high, right? It's getting out there now. If you go and look on, forums, places where people talk, you'll see that pretty much everybody out there in the world knows that pretty much everybody in college is cheating right now. And that is lowering the value of your degree, right? People involved in those conversations are not just random moms and dads. Those are people who review transfer applications. Those are people who review grad school applications. Those are people who hire. Those people all know that while there's this cheating going on, the value of the degree is going way down. Because no longer does having an A in this or that class mean you actually learned this or that material. I'm trying to stop that. So don't cheat in my class. If you cheat in my class, I will catch you. If you cheat in my class, not only will I catch you, but I will refer you to the Student Affairs Office. I will start a conduct trial, and I will go after harsh sanctions. Here's the flip side to that, the deal that I make with you. If it's getting close to a test and you catch your brain doing that thing where you start to think, where can I hide the extra phone, or what app should I use, or where can I tape the sheet, or how can I have somebody over here that the camera won't see or hear? As soon as your brain does that little mode flip where you go from studying to thinking about how to cheat, catch yourself and reach out to me instead. I promise I will work with you to help the test go well. And I'll bend over backwards. I will. I'll give you personal one-on-one office hours. I'll hook you up with private tutors. I'll get you extra material, videos, anything. If we have to, I'll move the test. Fuck it, right? Somebody's going to be sick that day. I'm going to have to do a makeup test anyway. I'll let you take the test a week later when they do, if you need it. I would way, way, way rather give you an extra week to prepare than have to catch you cheating and send you off to Dan Rodkin and see you get a ZF in the course, or God forbid, get expelled or something like that. That stuff sucks. I understand that it's very tempting. I understand that you may have gotten away with it in the past. You're not going to get away with it here, but I'll help you. I'll help you make sure you don't need it. And then you'll feel much better about it. I'll feel much better about it. We don't have to deal with Rodkin's office. You don't get nasty shit on your transcript. We all move on happy, healthy. Like I said, willing to be super duper flexible and helpful, willing to move things around for you pretty much to the end of the earth. Even if we have to do an incomplete in the course and give you a couple extra weeks before the final, I'll fucking find some way to get you the time you need to study. But don't cheat, right? If you cheat, I will catch you. When I catch you, I will fry you as hard as I can. Please don't do that. Little more context, background story. I told you I caught 6 on one test over the summer. My record is 9 on one test in the fall of 2020. 9 people cheating on the Calc 2 final. That was bad. That fucked my statistics for the year. But I still don't care, right? Because it matters that getting a good grade means you learned the material. Take the time to learn the material. I'll give you the extra time if you need it, but don't try to cheat on my tests. Okay. I know that's unpleasant. Let's get back to the good stuff. Here's the course calendar. This is a rough outline of when we're going to cover what stuff. If you're doing really well with a certain section, everybody's getting it really quick, we may move a little faster. If we're slowing down a little bit, then it's because I notice people having trouble with the homework or quiz scores go down or things like that. So I may move this around a little bit, but you can count on this being a rough arrangement of when things are going to happen. So the first week, we're going to cover a bunch of stuff from chapter 1, stuff that we should know from previous algebra classes. Then we're going to talk about functions and their graphs kind of very generally. We're going to introduce a slightly deeper way of looking at the graph of a function. And then from there, we're going to talk about functions in general, just like we said earlier, studying functions in great generality. Once we get to this section on one-to-one functions and their inverses, we will be ready for exam 1. After that, we're going to talk about quadratic functions and then polynomial functions. And then we're going to talk about like dividing polynomials, a few important theorems about polynomials, rational functions, and polynomial and rational inequalities. Then we'll be ready for exam 2. That will be midway through October. After that, we're going to start talking about exponential functions. I'll teach you about the number e and the natural exponential function e to the x. Then we will talk about their inverses, which are logarithm functions, some algebra properties of logs, and we'll learn how to solve equations and do cool shit with those. Then we will be ready for exam 3. That will be in the start of November. After that, we are going to talk about systems of equations, which kind of naturally leads to the study of matrices. After that, we are going to talk about matrices as their own algebraic objects, like matrix equations, which are really cool. We'll talk about matrix inverses, determinants, Cramer's rule, and then some important applications like partial fraction decomposition. This will come in big handy in Calc 2 and in differential equations. Then we'll be ready for exam 4. And then the last bit of material we're going to cover sequences and series, a bunch of different kinds of sequences, something called the binomial theorem, which is a cool way to multiply out like really, really big expressions without actually foiling every last thing out. Then we'll talk about conic sections, parabolas, ellipses, hyperbolas, and circles. That last bit of material, the chapters 11 and 12 stuff, is not going to be tested on any midterm. It'll only be tested on the final. The final, again, is December 7th, and that's the syllabus. Any questions on the course calendar? Okay. Any questions from elsewhere in the syllabus? The policies, grading scale, any stuff like that?
I have a question about homework.
Sure.
So when we start it, is it like right when you start, you have to finish all of it, or can you like do some and then go back?
Oh, no, yeah, you can do some and go back. Oops, sorry. You can do some and go back. The homework is, and until the day the homework is due. So the homework set that's up right now, let's take a quick look. You guys are section 009, here it is. So this is the homework set that's up for you right now. And you can come in here and work on this anytime you want up through next Tuesday at the start of class. You can do 5 problems and then quit and come back. Those 5 problems will save and you don't have to redo them until the day the homework is due. And then you won't be able to access it beyond that unless you put in an extension request.
Okay, thank you.
All right, you see there's about 40 problems here, I think 37, 38 problems. There is going to be a second homework set this week. I will be releasing another one on Thursday, and that one will also be due on Tuesday. And then we're going to get into our normal pattern. Homework on Tuesday, due Thursday, homework on Thursday, due Tuesday. And we'll just keep going like that for the rest of the semester. Any other questions about this sort of bookkeepy, syllabus, policy, how class works sort of thing?
For tests, can there be like credit for like writing down problems or showing our work, or no?
Yes, absolutely. I'm glad you asked that. So I don't know if I've populated your Canvas course with this stuff yet or not. No, I haven't. Let me show you my other one. So I will be copying all of this material into your Canvas course from the Canvas course I'm looking at right now. There's a spot for the homework, 45 points, spot for the quizzes, 75 points. And then you'll see each exam actually has 2 links. So this is where you're going to go to take the test. And then as you go through the test, you're going to write out solutions to each of the problems. As soon as you finish that, you're going to come over here and submit scans of your written work. So yes, the way the test works, there's some true-false questions, there's some multiple choice questions, and then the bulk of it is free response questions. The true, false, and multiple choice are just right or wrong, right? Either you get all the credit or you get none based on whether your answer is correct or incorrect. But the free response questions I grade out of 10 points, and it's all about the written work. So yes, your work will be graded here. There's lots of partial credit. All right. Any other questions about this sort of stuff? Okay, I did see in chat earlier some people having trouble with the WebAssign registration. Please do try to get in there, get registered for that today, because again, while there's only one homework right now and it's due on Tuesday, there's another homework coming on Thursday, which will also be due on Tuesday. You've got lots and lots of homework. You need to work on that stuff every day. That is the way to stay on top of it. If you put in a little bit of time every day, you're active on the Discord server and talking about this stuff with other people, you'll be amazed how quickly it gets into your brain. It just becomes like a part of your culture. If you don't do that, if you wait to do the homework until the last minute, you try to cram it out, or God forbid, use some horrible thing like photomath, you're going to have a bad time, right? That's French frying when you shoot pizza. Will the exams require calculators? No, you don't need a calculator for the tests. I write everything to make sure that the arithmetic is very simple, but if you do want a calculator, the only one that's allowed is the TI-32XS. It's like a $10 calculator from Walmart, so it's certainly not required, but the only one that is allowed is this one. No other calculators are allowed. All right. Anything else we'd like to ask before we get into the mathematics itself? Okay, I don't remember if I said this before, but I'll say it again just to be careful. Anything that I write over here goes into your notes. So make sure you've got your notebook out, you got your pencil and paper, you're ready to take notes. Just the act of writing shit down helps you remember it. You'd be surprised. So even if you don't think you're ever going to refer back to it, write it down as we go, and you'd be surprised how much it helps you remember. If I go too fast or you miss something, don't hesitate to tell me to slow down or go back. I'm always happy to do that. So we're going to start by talking about number systems. Classes like college algebra kind of presuppose that everybody knows what real numbers are, and like there's somehow this totally natural thing, which is bullshit. They're not at all. The real numbers, the number system that we're going to work with mostly in this course, is a relatively recent invention or discovery, depending on how you look at it. Richard Dedekind in the late 1700s was the first person to really understand what real numbers as a set were. Before then, we had lots of other different number systems. The first one that people started fiddling with is this one. And I'll explain the notation here. So when you see curly braces, like a bunch of stuff inside curly braces, that means the set containing this stuff. So this would here be the set containing the numbers 0, 1, 2, 3, and then the dot, dot, dots mean it keeps going like that. So 4, 5, 6, 7, 8. These are the non-negative whole numbers. There's a name for these. Some people call them the counting numbers. Most people call them the natural numbers. And depending on who you ask, some people will say 0 should be in this set. Some people will say 0 should not be in this set. So for example, in France, 0 is always considered a natural number. In Germany, 0 is not considered a natural number. But when I refer to the natural numbers, I'm always including 0. And if I want to refer to this set as a single object, I will use this notation. It is a blackboard bold N for number or natural. If you add two natural numbers, you get another natural number. If you multiply two natural numbers, you get another natural number. That means this forms an algebraic structure called a monoid, which is not all that nice. Pretty quickly, people realize in addition to adding and multiplying, we want to be able to subtract. And right away, you get into trouble if you're trying to do that in the natural numbers. So we discover or invent, depending on how you look at it, the integers. That is the whole numbers, positive and negative. So this set is called the integers, aka the whole numbers. And if I want to refer to this set as a single object, I will use this symbol, which is a Blackboard bold Z, stands for the German word Zahlen, which is German for number. So the integers are nice. They form an algebraic structure called a ring, because if I add any two of them, I get something in the set. If I subtract any two of them, I get something in the set. If I multiply any two of them, I get something in the set, right? Sums, differences, and products of integers are other integers. But you can't divide. If you start dividing integers, maybe you get another integer, maybe you don't. So the next thing people start playing with is the set of all fractions of integers. So this is read as the set of all the things that form m over n. The vertical bar here means such that, and then m and n are integers. Does anybody know the name of this set?
Rational numbers.
Yeah, very good. This is called the rational numbers. And again, the vertical bar here, this stands for the word such that. So this is the set of all m over n such that m and n are integers. And yeah, exactly. This is called the rational numbers. And the symbol we use to refer to this set is a Blackboard bold Q, Q for quotient, like a fraction, a quotient. Now, there are plenty of real numbers that are rational numbers, right? Every rational number is a real number. 1/2 is 0.5 is a real number. 3/4, 0.75 is a real number. But there are also lots of numbers that are not rational numbers. We call those irrational numbers. For example, the square root of 2 is not a rational number. There's no way to write the square root of 2 as a fraction where the top and bottom are both integers. So to expand our view a little bit beyond this, we have to include the irrational numbers. If we take the rationals together with the irrational numbers, we get the real numbers. Which I'll refer to with a Blackboard bold R. In this class, we work almost exclusively with the real numbers. Sometimes we'll work with complex numbers, but I'll tell you when we're going to do that, right? So outside of those few special moments where we work with complex numbers, anytime you see a variable like x or y, you can assume it represents a real number. There's no easy way to write down a rule like this for real numbers. There are some, but they're kind of like cheating. Like I could say all possible decimal expansions. That's the set of the real numbers. But there's a better way to think of it, and I'm going to share that with you now. So I'll give you just a minute to catch up if you're still writing. Oh, hey, little baby. My son's chilling on the swing over here, just being cute. All right, I'm going to turn the page in about 10 seconds. Okay, here we go. So how do we think of the real numbers? We think of them as a line. Specifically, I'm going to give you 3 properties here that only the set of real numbers have. So the real numbers are the unique number system which is first totally ordered. Leave some space. I'm going to come back and explain what each of these things mean. Totally ordered, complete, and a field. All right. So I'm going to explain what each of these things mean. But if you have a number system which is a totally ordered complete field, then that is the real numbers, up to what mathematicians call an isomorphism. What does it mean to be totally ordered? It means they can be put on a line. Now, the technical way to say this is given x and y real numbers that are not equal to each other, either x is less than y or x is greater than y. So you give me 2 distinct real numbers, one of them has to be bigger than the other. That's what it means to be totally ordered. The natural numbers, the integers, and the rational numbers are all totally ordered. The complex numbers are not totally ordered. That's a fun fact. The complex numbers have a partial order based on their modulus, but they're not totally ordered. Okay, what does it mean for them to be complete? This means there are no gaps on the number line. So no matter how much you zoom in and zoom in and zoom in on the real number line, you'll never find a hole. You'll never find a gap. If you think about the natural numbers, for example, 0, 1, 2, 3, 4, there are big gaps there, right? Between 0 and 1, there's a big fucking gap. And there are not any natural numbers between those. Kind of a consequence of this is that between any 2 distinct real numbers, there's not only one other real number, there's infinitely many other real numbers. Right? So if you take 2 numbers on the line, right, look at me over here. If you take, here's your number line. You take any 2 numbers on that number line and you zoom in. There's going to be not just one other number, there's infinitely many other numbers in between them. One other way to think about this is to say that there's no next real number, right? Take your favorite real number right here. And then suppose this guy right here is the next one. Well, zoom in. There's infinitely many other real numbers in between. So this couldn't be the next one. There's a shitload of them over here that are closer. And if you pick one of those and think, oh, maybe that's the next one, and zoom in, there's infinitely many others in between. There's no such thing as like the next real number. 2 is not the next number after 1. 1.1 is not the next number after 1. 1.0001 is not the next number after 1, because you can zoom in and find infinitely many more in between. In other words, kind of one last way to think of this, the number line is solid. No matter how much you zoom in, you'll never find a hole or a gap or anything like that. It is a solid chunk. The word mathematicians use for this is it's a continuum. All right, and then finally, it's a field. What do we mean when we say the real numbers form a field? Well, this means that given any real numbers x and y, we can form x plus y, x minus y, x times y, and if y is not equal to 0, we can form the quotient x over y, and all of these are themselves real numbers. So remember what we said about the integers. If you divide two integers, you don't necessarily get another integer. But if you divide two real numbers, as long as the bottom isn't 0, you will always get another real number. So mathematicians break different number systems down into categories based on the kind of algebra you can do with them and stay within the set. I can add two natural numbers or multiply two natural numbers and get another natural number. But if I subtract or divide, I don't get another natural number, at least not necessarily. So they are kind of the least interesting of these number systems. Integers are a little more interesting. If I add or subtract or multiply any of those, I get another integer. So we call that a ring. That's a slightly more interesting than a monoid. And then the rational numbers also have this property where if you add, subtract, multiply, or divide any rational number, you get another rational number. So the rationals and the reals form this sort of an object called a field. The complex numbers also form a field. The real numbers are special though, because it's sort of the simplest set where you can do calculus. The rationals are totally ordered and they are a field, but they're not complete. And completeness turns out to be the really important feature that we need for calculus. If you want to think of the rational numbers, picture your solid real number line. The rational numbers are like a faint sprinkling of dust over that line. If you were to look at your real line and pluck out all the irrational numbers, what would be left are the rational numbers. And then necessarily, because you've removed shit, now you've got gaps. And you can't have gaps and do calculus. You can really only do calculus if your number system is solid. It's all about like motion and time. So the real numbers have these special features. They are complete, they are totally ordered, and they form a field. And those are the things that we need in order to do calculus. So we will be doing all of our work in the real number system because that's where you're going to be doing your calculus work. Okay. Some of the very basic questions in your first homework set ask you like, is this thing a natural number or is this thing a rational number? And those are all questions that I trust you guys know how to answer just based on the definitions. So what I would like to do now is look at kind of a few sort of just very basic algebra properties and simplifying fractions, get a little bit of practice with that stuff to make sure we're all on the same page because that also appears in your homework. And I want to make sure we have those fundamentals down before we get into anything tougher. Okay, so before we do that, let me remind you some rules for exponents. And remember, anytime I write down a variable, I'm assuming it's a real number. So these rules apply to real numbers. First, if I take a product of two numbers, a times b, and I raise that whole thing to a power, m, then that's the same as a to the m times b to the m. This only works with multiplication and division. It does not work with addition and subtraction. So let me make a little comment here. Like a plus b to the m or a minus b to the m is super duper not equal to a to the m plus or minus b to the m. This never works. Or I should say it only works if one of a or b is 0. Okay, but don't ever do that shit. Next rule for exponents is that if, let's see, what order did I do this before? Oh yeah. So if I take some number a and I raise it to the m, and then I multiply that by the same number a raised to the n, this is like a times a times a times a m times. This is like a times a times a times a n times. So you have m plus n copies of a sitting here. That means that's a to the m plus n. And this works even if the powers are not whole numbers. This works great for fractions or irrational numbers, just fine. There is a division version of this where if you take a to the m and you divide by a to the n, instead of adding the powers, you subtract them. And this works no matter which one is bigger and regardless of whether any of them are whole numbers or not. Next, if I take something and raise it to a negative power, a to the negative, I'll say m here, I'm using m's first, then that's the same as the reciprocal of a raised to the positive n. And be careful with this, there are ways to get this wrong. This has nothing to do with the power being a fraction. However, if you do have a power which is a fraction like a to the 1 over m, that can also be interpreted as the mth root of a. And then one more, if you have something like a to the n over m, so you're raising a number to a power and that power is a fraction, then this can be interpreted two different ways. This can be interpreted as the nth root of a to the n, or as the nth root of a, this is an m, all raised to the power of n. And we can actually get these two facts from the very last rule that I'll share with you here, which is if you take a power like a to the m and you raise that all to another power, this is the same as multiplying those powers. This is a to the m times n. All right, so these are your sort of basic rules for exponents, stuff that I'm sure you guys have seen in one context or another before. But I want to give us a little bit of practice with these before we do stuff that depends on them. I'll hold here for just a second. Is there any question about what's written there, notation, anything like that? Do a quick time check. Okay, we got just about 6 minutes left, which is just enough time for me to show you one or two little examples. So here we go. We ready? About 10 seconds. Remember, if you do miss something on the notes, I do post the recorded lecture to YouTube. It'll be up later today. So I advise you go back, rewatch the lecture, fill in any gaps in your notes. Here we go. First few little example problems to work. I'm just going to ask us to simplify some stuff. Let's simplify some stuff. So e.g., I'll always preface examples with e.g. That's a Latin abbreviation for exemplus gravi, or many examples exist. For example, simplify the following. Let's start with the cube root of x to the 3/4 times a to the 9. And you'll see with my radical symbols, I always like to put a little tail at the end so you know where it stops, because if you have other stuff over here, you want to be clear what's in there and what's not. Let's also see if we can simplify something like 1 over the square root of y times the square root of y. So one big square root with underneath it y times the little square root of y. Okay, and then for our last example, let's see if we can simplify something like 1/2 divided by 2 minus 1/7. All right, something a little bit messy with some fractions. The fraction stuff is there in your homework too. I'm not explicitly writing down the rules for fractions because I'm supposed to trust that you know this from before, but I think it's worthwhile to just make sure we're on the same page about how to do that sort of shit. We're going to start at the top. Can anybody suggest a rule that we could use to get started with part A? The two things under here have different bases, right? One is base X, the other is base A. So I can't like combine these. The only other thing that's going on is the cube root here. So what can I do to try and clean this up? You can hold spacebar to talk, kind of like a walkie-talkie, or you can type in the chat. Yeah, we can't really combine those, right? There's no nice way to multiply those because I don't know what X is and I don't know what A is.
Wouldn't X and A be the power to 1/3?
Very good. Yeah, so we can use that fifth rule. All right, if I look down here at the fifth rule, if I have some shit under an mth root, that's the same as that shit raised to the 1/mth power. So this guy is the same as big parentheses, x to the 3/4 times a to the 9, all to the 1/3. I'm going to do my best to write solutions in purple. So I can't cube it because I'm not allowed to change the value of the expression. If it was a part of an equation that I was trying to solve, maybe cubing both sides would be good to get rid of the cube root. But here I'm just trying to simplify. So I don't want to change anything. I just want to rewrite it in a way that lets me clean it up. So rewriting this big cube root as a big 1/3 power is a good first step because now I can use one of these other rules. Does anybody see anything else here that we could use? So I've got something times something else, and it's all being raised to a weird power. That looks a lot like this, right? Something times something else, all being raised to a power. So what I'm going to do is I'm going to give that 1/3 power on the outside because these two are being multiplied. I can give that power to each one of them on their own. Since each one of those things is itself a power, I'm going to do it carefully. I'm going to give each one their own little parentheses. So this is x to the 3/4 all to the 1/3 times a to the 9 all to the 1/3. And that's using rule 1. I'm going to just put a little equals and a dot, 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 and continue this down here. Dot, 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 equals. So first I use the rule that says this cube root is the same as a 1/3 power. And then I use the rule that says, okay, inside there, I've got two things being multiplied, all raised to some power. So I can just give each one the power on their own and then multiply the result. To clean it up from here, I just focus on this guy and then separately focus on this guy. I just handle them one at a time. So in the first piece, I have x to the 3/4, and that's all being raised to the 1/3. Which rule tells me what to do with that?
The seventh rule?
Yeah, very good. The last one, right? Those are each powers raised to powers. So x to the 3/4, all raised to the 1/3 is x to the 3/4 times 1/3. Like this, all in the power. And I can do the same thing with the other piece. That's a to the 9 times 1/3. Like this. And now we need to clean up those fractions. Remember, you multiply fractions straight across. So 3/4 times 1/3 is 3/12. You can simplify that to 1/4. Or you can note that the 3's here cancel. There's a factor of 3 in the top. There's a factor of 3 in the bottom. That's how I would think of it. These cancel. So this first piece is just x to the 1/4. And the second piece is similar. A to the 9 times 1/3. Well, that's 9/3 or 3. Or you can think of 9 as 3 times 3 and cancel one of the 3's. You just get a cubed. And then if you really want to, you could rewrite this as a cubed times the 4th root of x. And on a test, for example, I would be just as happy with this as I am with this. Either one is fine. The only reason I wrote the a cubed first is because it looks nicer to have all the stuff that's not under the radical out front. But you could write it as the 4th root of x times a cubed if you wanted. Just make it clear that the a cubed is not under the radical. Okay, a little bit tricky, right? Even if we know this stuff, it's a little bit tricky to apply it, and that's why we want to practice. Who can help me with the second problem? Downstairs here, we have something that's kind of similar looking to what we had here. Only both of these are the same variable. Instead of x and a, it's y and y. Yeah, Camden suggests we rewrite all of this as something to the negative 1st power. We can do that. I like that. We can rewrite this as big square root y, little square root y underneath, all to the negative 1st power. Right? Having some chunk downstairs is the same as having that chunk upstairs to the negative 1st. So this is valid. How can I clean up the radicals? This expression itself looks a little intimidating, right? But if we look one piece at a time, right here, this little root y inside the big root, that's y to the 1/2. And you know that this big root is really a 1/2 power also. So let me do this. I have my big parentheses on the outside with the negative 1st power. And then within that, I'll have a little parentheses. Inside that is y times y to the 1/2. And then that little parentheses is raised to the 1/2. And Emma is correct in the chat. That is where we're going, yes. So the y times square root y, this piece right here, is this piece right here. y times y to the 1/2. And since that was all under a square root, that is all being raised to the 1/2 power here. Now, following our order of operations, we need to look inside those parentheses. This y times y to the 1/2. What can I do with that? Which one of my rules can I use here?
Rule 2.
Very good. Y is the same as y to the 1. So I have y to the 1 times y to the 1/2. That means I'm going to have equals. Here's my big parentheses with the negative first power on the outside. Here's my little parentheses with the 1/2 power inside. And then y to the 1 times y to the 1/2 is y to the 1 plus 1/2. What is 1 plus 1/2?
Three over 2.
Yeah, it's 3/2, right? I need to have a common denominator. So this guy has denominator 2, this guy has denominator 1. So we multiply by 2 over 2 here, and you get 2 over 2 plus 1 over 2, which is 3 over 2. So this is y to the 3 over 2 on the inside there. Alrighty, we are almost done. Again, I'll put my big parens with the negative first power on the outside. Inside here, I have y to the 3/2 all to the 1/2. So that's y to the 3/2 times 1/2, which is 3/4. Right, fractions multiply straight across. So 3 over 2 times 1 over 2 is 3 over 4. And then finally, using that same rule, I can multiply this power and this power. So this is y to the negative 3/4. Yeah, that's sort of the idea, Gavin. Yep. We're using the second root, so it's like a 1/2 power. So here, this is like the square root of y cubed all to the 1/2 power, or the square root of y cubed, which is y to the 3/4, or the fourth root of y cubed. All right, and we could leave it like this if we wanted to, or we could rewrite this as a fraction. There's lots of options here. Just for fun, let me show you one other way you could write this. You could write this as 1 over the 4th root of y cubed. If you wanted to. Either one would be perfectly acceptable. Alrighty. Now, I remember when I was taking algebra classes, there was a day I'll never forget. I went home and cried. I just cried. I remember screaming like, this shit is impossible. And it was all this sort of stuff, right? Like powers with fractions in them. And just going home and screaming like to myself, my roommates, anybody who would listen, this fucking shit is impossible, blah, blah. It's not. It takes time, but it's not impossible, I promise. Fractions are also a little bit weird to deal with on their own, even outside the whole exponent thing. So let's fiddle with this a little bit. Division's a weird operation because it's not associative, it's not commutative. It doesn't do any of the nice things that like addition and multiplication do. Addition and multiplication fucking do whatever order you want, move things around, swap parentheses, doesn't matter. Division is not like that. So when you have compound fractions, fractions within fractions, always check to see where is the big fraction bar, because that implies some parentheses. The way to think about this, and the only way to think about this, is like this. Big fraction bars imply parentheses. We don't always write them, but if you're having trouble with your order of operations, getting the wrong thing when you put it in the calculator, this is why. I promise you this is why. If I typed 1/2 divided by 2 minus 1/7, it would do 1/2 divided by 2 and then subtract 1/7, which is not the same as what we have here. All right, this is 1/2 divided by the chunk, 2 minus 1/7, which is very different. Again, we follow our order of operations. It says clean up inside parentheses first. The top can't clean it up, it's just 1/2. The bottom though, here we can clean things up. 2 minus 1/7. I'm subtracting some numbers. Let's rewrite this as one fraction. So the top I leave as 1/2, and I'll leave it in parentheses because it's always nice to remind ourselves. Big fraction bar, and then downstairs, how do I subtract 1/7 from 2?
You need a common denominator, so times 2 over 1 times 7.
Yeah, exactly. Same thing we had to do here, right? Or I wanted to add 1 to 1/2. I need a common denominator. So the 2 already has denominator 1. The 1/7 has denominator 7. So 7 is going to be our easy common denominator. To write 2 as a fraction whose denominator is 7, I multiply by 7 over 7. And I get 14/7 minus 1/7. And I think everybody would agree that 14 over 7 is the same as 2, but this is how we have to write it if we want to subtract those. And now downstairs here, 14 over 7 minus 1 over 7 is just 14 minus 1 over 7, or 13/7. So the whole thing is 1/2 divided by 13/7, like this. And now that we get to this stage, and we've got our parentheses in the right place, right? Without any parentheses here, and if I used the same length fraction bar, this would be fucking confusing. 1 divided by 2 divided by 13 divided by 7. But with the big fraction bar and the parens, we know exactly what to do, right? What do I do?
Flip 13 over 7, make it 7 over 13, and times it by 1/2.
Perfect. I leave the top alone. And I flip and multiply by the bottom. That's it. And now fractions multiply straight across. So 1 times 7 is 7. 2 times 13 is 26. So this whole mess here is really 7/26. We'll be using fractions a lot in this class. Don't shy away from them. I know that college algebra, you've got the TI-84, it's got a little fraction button. You can escape college algebra without actually learning how to do this stuff. No more, right? That's not going to work anymore. One of the reasons we chose the TI-32XS for this class is because it doesn't have that ability. You need to learn how to grapple with these things barehanded, and you will. Right, you will, and I'll work you through them. We'll do lots of examples where you have to go through this stuff by hand, and if you pay attention and practice and do the homework honestly, you will be a master of this stuff in no time. I do think we're about out of time for today, so I'm going to go ahead and wrap us up here. Oh yeah, we're late. I'm so sorry. Thank you guys for sticking around. All right, I'm going to end the meeting here for the day. It's going to go up on YouTube in a little bit. Remember, office hours Monday, Wednesday, Friday. If you need to get a hold of me outside that, Canvas messages are the way. If you have any questions or anything you want to talk about, don't hesitate to reach out. Otherwise, I'll see you guys on Thursday. Get into WebAssign, get started on the homework. You really want to do that. Please do that today. All right, that's it. Take care, guys.
Take care.
Thank you.